We've all heard the incredible potential of AI in education, truly personalized learning, tools that can adapt to every student, assessments created instantly. It sounds amazing.
Yeah, it really does.
But then you actually try using these tools in the real world, in a classroom, with your specific curriculum, and you quickly run into, well, frustrating limits.
Exactly. AI can be brilliant at generating text, but it's prone to making things up, what we call hallucinations.
Right.
It can struggle with consistency, especially when dealing with complex ideas, and getting it to reliably align with a detailed, specific learning standard or curriculum framework. That's a huge challenge right now.
It's like it knows how to talk about a subject, but doesn't fundamentally understand the structured knowledge within that subject or how it's supposed to be taught and learned according to, a specific plan. And that lack of grounding makes it unreliable for critical tasks like assessment or core instruction.
That's precisely the problem this deep dive tackles. We're diving into a lecture note by Dr. Jaehwa Choi, an associate professor at George Washington University, who's also known for inventing the CAFA platform.
Okay.
And he's proposing a really systematic solution here.
And that solution is called COREA, the Curriculum Ontology Reservoir for Education via AI. So our mission today is to really unpack this. We want you to walk away understanding what COREA is, why it's necessary, how it's designed, and its potential to finally make educational AI truly curriculum-aligned, accurate, and genuinely trustworthy.
Yeah, think of it as exploring a blueprint for AI that works with the structured goals of education, not just sort of alongside them.
Okay, let's start with that problem space the source lays out. Generative AI, like the large language models we hear so much about, they offer undeniable potential for things like creating personalized content or assisting teachers.
Right, the possibilities feel vast. But Dr. Choi's note immediately zeroes in on those critical limitations we just touched on. AI's tendency for factual inaccuracies, those hallucinations, well, that's a non-starter in education.
Absolutely. You simply can't have an AI teaching incorrect facts.
And there's a significant lack of conceptual consistency. AI might present an idea one way in one response and a slightly different, maybe even contradictory way in another. In education, where building a solid understanding of interconnected concepts is key, this inconsistency is a major barrier.
And then there's the big one for educators, the persistent difficulty aligning AI output with specific curriculum documents and learning standards. You might need content that hits a very specific depth or relies on particular prerequisite knowledge defined by, say, your state or district standards.
Yeah, current AI struggles to nail that reliably.
So why does this happen? The source explains why these limitations exist. Traditional language model, only generation alog, essentially just predicts the most likely next word based on patterns it learned from vast amounts of data.
Right, it doesn't possess a deep, structured understanding of the subject matter itself. It's statistical prediction, not knowledge-based reasoning. Precisely. Retrieval Augmented Generation RAG improves this somewhat by pulling information from external documents. But as the note highlights, it's still limited if those external sources aren't themselves structured, organized, or grounded in a formal way.
So the AI can retrieve text, but it still struggles to reason about that text in relation to a curriculum structure.
Exactly. And fine-tuning existing AI models. While helpful for specific tasks, the source points out that fine-tuning is often inflexible. It's hard to update quickly as curricula evolve or to adapt to the granular, specific standards needed across different schools or regions.
So it sounds like this all underscores the core argument. To make AI reliable in education, you need a systematic, explicitly structured, and trustworthy knowledge base that the AI can actually reason with.
Yes, exactly. And this is particularly vital for movements like TEAM, the Teacher-Empowered Assessment Movement, which aims to give teachers tools to build their own AI agents.
Right, those teachers need a reliable foundation, so the tools they create are accurate and curriculum aligned. They can't be expected to build that foundation themselves.
And it also ties directly into theoretical frameworks like Ontology Model-centered Generation, OMG, which is a core concept within the CAFA ecosystem. OMG basically argues that AI generation for complex domains must be guided by explicit, validated knowledge structures.
Okay, so the problem is clear. AI needs structure, consistency, and curriculum alignment, which current methods struggle with. The proposed solution is COREA. What exactly is it?
Well, the definition from the source is key here. COREA is described as a meticulously engineered, structured knowledge base. Its purpose is to systematically digitize, organize, and represent educational content, focusing primarily on the formal modeling of curricula using ontology models.
Ontology model.
Right. So it's far more than just a collection of documents. It's a semantic network capturing the meaning and relationships of curriculum knowledge.
A semantic network. So it's not just storing facts, but mapping how those facts and concepts connect to each other, like prerequisites and things.
Exactly. Its function is to serve as a dynamic, comprehensive repository for this semantically enriched curriculum data. This means defining core concepts within a subject like photosynthesis or quadratic equations, mapping their intricate relationships, prerequisites, part-whole structures, causal links, and connecting them to learning objectives, assessment criteria, and even relevant pedagogical strategies.
Okay, so its job is to be the authoritative, navigable source of curriculum knowledge, but crucially, in a format AI can actually use effectively.
Right. And the source highlights some key characteristics that make this possible. One fundamental aspect is that it must be both machine-readable and human understandable.
That duality seems crucial. Why both?
Well, machine readability means AI systems and software can directly access, parse, and act on the knowledge stored in COREA. This uses formal ontology languages, structured data formats, APIs, things computers understand. This allows AI to use COREA to build content, analyze curricula, generate assessments automatically, things like that.
Got it. But then for educators, for curriculum designers.
Exactly. You need to be able to look at COREA and understand it, verify it, and trust it. That's where human understandability comes in. Clear naming conventions, visualization tools, good documentation. These are essential for building what the source calls ontological commitment, basically ensuring the experts who build and validate it agree that it accurately represents the curriculum.
Makes sense. What else defines it?
Another defining characteristic is that it's fundamentally curriculum aligned. This is really COREA's whole reason for being to connect AI output directly to educational standards, objectives, and sequences.
Which means painstaking work mapping the concepts and relationships within COREA back to specific official curriculum documents, competency frameworks, learning taxonomies, all that official stuff.
Precisely. This mapping is the stable anchor the source mentions. It guarantees that when an AI tool uses COREA, its output supports the intended educational outcomes defined by the actual curriculum.
And underpinning all of this is that it's ontology-based. Let's break down what that means again. It's not just a list of terms, right?
No, definitely not. It means explicitly defining those concepts. Think force, democracy, metaphor, their properties, maybe like a concept's typical grade level, or its estimated difficulty, and crucially, those rich, explicit relationships between them.
Can you give us an example of those relationships in action? How does that help the AI?
Okay, sure. Think about math. An ontology defines algebra as a type of mathematics. It defines solving linear equations as a prerequisite for solving quadratic equations.
Okay.
Or in literature, maybe a climax is part of a narrative structure. This semantic precision, defining these links, is what allows AI not just to find text about these things, but to actually reason about how they connect, infer dependencies, and generate content that respects this structure.
That's where the power shifts from just generating plausible text to generating pedagogically sound, connected content. It understands the why behind the sequence.
Exactly. Now, moving on, the source clarifies what kind of knowledge COREA is primarily designed to model. Its core focus is on the relatively stable knowledge within specific educational domains, the curriculum itself, what the note calls contents and components, basically what is known, what is supposed to be taught.
So this is the disciplinary knowledge, the facts, concepts, skills. What does modeling this look like in practice? The source gives several concrete examples, right?
It does. First, curriculum structure. This involves formally defining standards, subjects like science or social studies, topics within those, subtopics, key concepts, facts, principles, procedures. And importantly, it models both the hierarchical structure, like biology is a subject within science, and the mereological or part-whole relationships, like a cell membrane is part of a plant cell.
So the AI can understand the flow and prerequisites automatically. Like, it knows you need cell structure before photosynthesis.
Yes, exactly. Second, assessment blueprints or measurement models. COREA provides the underlying semantic structure for designing valid assessments. It specifies the constructs to be measured linked directly back to the curriculum ontology, like applying Ohm's law, or analyzing primary historical sources.
And it details content domains, maybe suggests item types like multiple choice or
Right.
essays, and crucially, links to the cognitive skills targeted, perhaps using something like Bloom's taxonomy levels.
Right. This ensures assessments truly measure the intended learning outcomes defined in the curriculum, not just some vaguely related knowledge.
Okay, and the third example.
And third, resource catalogs. COREA helps organize learning materials, textbooks, videos, online resources, OERs, by tagging them not just with keywords, but with relevant concepts, objectives, and competency codes defined in COREA.
Ah, so it's much more powerful than simple keyword search. It lets an AI recommend specific, highly relevant materials based on where a student is in the curriculum map defined by COREA, or maybe based on specific concepts they're struggling with.
Exactly. It enables much smarter recommendations. The source does briefly mention that while COREA focuses on this sort of static content knowledge, ontological modeling can also apply to more dynamic aspects like learning progressions or instructional strategies. But COREA's immediate focus is providing that foundational, stable content map.
Okay, so we have this vision of a structured semantic curriculum map. How is COREA actually designed and built? The source keeps coming back to the centrality of ontology models, defining concepts and relationships, facilitating that shared understanding needed for collaboration.
And it introduces evidence-centered design ECD as a major guiding framework for its structure. ECD is it's a systematic way to design assessments and learning experiences. The goal is to make the chain of reasoning explicit, from what a student does, their actions or responses, to what we can infer about what they know, can do, and understand, their KSA's knowledge, skills, and abilities.
It's essentially building a clear argument, a logical link for why a student's performance means they've achieved a certain level of understanding.
Precisely. ECD involves several models: domain analysis, domain modeling, student model, task model, evidence model. Now, here's where it gets really interesting, and this is a significant insight from the source. COREA isn't just informed by ECD. COREA provides the structured knowledge that makes ECD computationally viable, especially when you're working with AI.
So it's not just aligning with ECD principles, it's providing the necessary data structure for an AI system to actually execute an ECD-based design. That's a key difference.
Exactly. Let's walk through it. The domain analysis step in ECD is about defining those KSAs. COREA is the structured output of this step. It encapsulates the KSAs, concepts, and relationships in a machine-readable format that AI can use directly, say, in prompts or complex processes.
Okay. And for domain modeling, that's about structuring the KSAs and their connections for assessment claims.
Right. COREA's ontological structures, those hierarchies, prerequisites, part-whole relationships we talked about, are the domain model. This allows AI to understand dependencies and navigate the knowledge space effectively to support assessment design or learning path generation.
Makes sense. What about the student model? That tracks what a student knows.
COREA provides the fine-grained definition of the concepts and skills that become the variables in that student model. So instead of just tracking algebra skills, you might track mastery of specific COREA-defined concepts like solving single-variable equations or understanding coefficients. This allows AI to make much more precise inferences about student mastery.
And for the evidence model, which defines how we interpret student actions.
COREA provides the semantic basis. The source gives a great example. If a student makes an error in a physics problem, COREA's structure can help an AI distinguish if it was a physics conceptual error, maybe misunderstanding conservation of energy, as defined in COREA, versus a basic math error, which would be a different type of concept or skill defined in COREA.
Enabling much more nuanced interpretation and feedback.
Yes. And finally, for the task model, which defines how to generate tasks that elicit evidence of KSAs, COREA directly provides the content targets. AI can use COREA's defined concepts and relationships to generate diverse tasks, like asking students to identify parts of a plant cell and explain their functions, based specifically on how those concepts and relationships are modeled in COREA.
So COREA provides the building blocks and the map for AI to implement assessment designs based on ECD principles. It effectively transitions ECD from being mostly a conceptual framework for humans to an operational one for AI systems.
That's the core insight, yes. COREA provides the structured, machine-actionable knowledge that ECD requires to function effectively in an AI-driven educational environment.
Okay, let's look at where COREA fits into the bigger picture, specifically within the CFA ecosystem. Dr. Choi is the inventor of CAFA, pronounced like kappa, right?
That's right, like Keyfried. And COREA is described as a critical piece, a cornerstone for ontology model-centered generation, OMG.
Okay, OMG.
So while OMG is the overall framework that says AI should be guided by structured knowledge, COREA is the concrete realization of that structured knowledge for curriculum. It provides the actual concepts, relationships, objectives, and standards that AI agents use as their primary reference point.
Got it. So COREA provides the stuff, the structured content that the OMG framework uses to guide the AI. It's the curriculum content, formalized and ready for AI prompt engineering or direct consumption by AI processes.
Exactly. This is how COREA, working through OMG within platforms like CAFA, grounds AI firmly in the curriculum. It allows AI agents, including potentially ones that teachers build, to generate content, assessments, and feedback that are rooted in this trustworthy ontology, significantly reducing the errors and inconsistencies you see with less structured approaches like log or basic RAG.
And this grounding sounds absolutely essential for empowering the teacher-empowered assessment movement team.
It really is. COREA provides the solid, pre-vetted knowledge base that enables teachers in team to develop their own curriculum-aligned AI agents without needing deep expertise in AI or ontology engineering themselves.
It removes a massive technical barrier, right? Teachers can focus on the pedagogical aspects, how they want the AI to interact, or what kind of learning experience they want to create, knowing the underlying curriculum knowledge foundation provided by COREA is accurate and aligned.
Exactly. It lets them focus on the teaching, not the underlying AI plumbing.
So we've defined it, seen what it models, how it's designed using ECD, and where it fits in CAFA and OMG. What's the practical payoff? What can COREA actually enable that we can't do easily now?
The source outlines some really transformative potential applications. First, and perhaps most directly impactful, is curriculum-aligned AI content generation. Because the AI is guided by COREA's explicit structure, it can generate accurate, relevant content that genuinely aligns with specific standards and learning objectives.
So imagine an AI generating lesson plans that automatically map objectives to COREA-defined concepts, or supplementary materials that accurately elaborate on specific curriculum points.
Or even educational video scripts that follow a pedagogically sound sequence defined by COREA. The source gives a concrete example. An AI could use COREA to generate 3 examples illustrating the concept of osmosis as defined for grade 10 biology, ensuring they highlight its role in plant cells.
Wow, that's incredibly specific and aligned. Much better than just asking for examples of osmosis.
That level of precision is hard to achieve reliably otherwise. It also enables highly accurate automatic item generation, AIG. COREA's detailed structure allows AI to create large banks of diverse assessment items, multiple choice, essay prompts, scenario-based problems, all mapped precisely to curriculum elements and cognitive skills defined in COREA.
Like the example, using the COREA definition of Pythagorean theorem and its associated application skills, generate 5-word problems suitable for a grade 8 mathematics assessment. It's building assessments directly from the curriculum blueprint, ensuring coverage and alignment.
Exactly. And as we mentioned, it significantly facilitates team by providing that trustworthy foundation, allowing teachers to leverage AI power without needing to become ontology experts.
And COREA also strongly supports personalized and adaptive learning paths. This sounds really powerful.
It is. It's rich, relational structure, defining concept dependencies and prerequisites, allows AI systems to dynamically tailor content, difficulty, and sequences to individual student needs and progress.
So like the example of a student struggling with solving algebraic equations.
Right. An AI using COREA could trace back through the ontology to identify potential prerequisite gaps, like maybe understanding variables or basic arithmetic operations, and then intelligently recommend targeted remedial content or resources that have been tagged with those specific COREA concepts.
Okay, that's true personalization based on the structure of knowledge.
And finally, perhaps one of the most important benefits, enhancing explainability and trust in educational AI. When an AI makes a recommendation, gives feedback, or selects a learning task based on COREA, its reasoning can be explicitly linked back to the specific COREA-defined concepts, relationships, or objectives.
So it's not a black box anymore. If an AI flags an error or suggests a resource, it can explain why based on the curriculum structure in COREA, maybe something like, you seem to be misunderstanding the relationship between voltage and current as defined here in the physics ontology.
Exactly. That transparency builds confidence in the AI's pedagogical soundness for both educators and students. You can see its reasoning is grounded in a curriculum that humans designed and trust.
Okay, so that's the vision and the potential benefits. It sounds fantastic, but this isn't a small undertaking, is it? The source acknowledges that making COREA a reality requires significant effort and resources. What are the essential requirements listed?
Yeah, it's definitely a major project. It starts with clear governance and a long-term vision. Building and maintaining something this complex needs a robust organizational structure and a strategic plan that anticipates how curriculum and technology will evolve.
And it demands a genuinely collaborative and interdisciplinary effort. You need curriculum experts, educators, ontology engineers, AI researchers, policymakers, all working together. Getting that ontological commitment, reaching consensus on how curriculum concepts are defined and relate across diverse stakeholders is absolutely crucial.
You obviously need a robust technological infrastructure. A scalable platform like CAFA is mentioned as necessary, equipped with specialized tools for building, editing, visualizing, validating, and managing the ontology itself.
And there's a need for standardized methodologies and quality assurance. You need agreed upon standards for how the ontology is designed and built, plus rigorous quality control processes. The source even hints at leveraging AI assistants, maybe like Omega, for ontology evolution and validation, which is interesting.
Definitely. And realistically, sustainable funding and resource allocation. This is a significant investment, both financially and in terms of dedicated human expertise, sustained over the long term.
Can't forget community engagement, training, and adoption strategies. The CAFA community, teachers involved in team, curriculum developers, they need to be involved from the start, trained, and see a clear path to adopting and contributing to COREA for it to really take hold.
And finally, interoperability and standardization are key. Korea needs to adhere to standards like RDFO OBUL and use open APIs so it can connect with other educational technologies and systems, preventing it from becoming just another isolated data silo.
Okay, so addressing all those isn't optional. They're really foundational requirements for career success. What's the proposed path forward then, according to the source? How do you actually start building this?
It's described as an iterative development process. You can't boil the ocean, right? You can't build the entire world's curriculum ontology in one go.
Makes sense.
So it suggests a phased approach, maybe starting with priority domains, core subjects like math or science, perhaps specific grade levels, and then gradually expanding. This helps manage the immense complexity.
And establishing clear mechanisms for community contribution sounds vital too. This needs to be a living resource, constantly updated and refined.
Absolutely. You need platforms, feedback channels, and working groups for educators and subject matter experts to contribute, validate, and refine the ontology. That's essential for its ongoing accuracy and relevance.
Integration with the broader CAFA ecosystem is also stressed. Seamless integration with the CAFA platform via APIs and aligning with frameworks like OMG and initiatives like Team ensures COREA actually serves as the operational foundation it's intended to be.
And they emphasize addressing scalability and maintenance right from the outset. This means developing tools to manage the sheer size and complexity of a comprehensive curriculum ontology over time, perhaps leveraging AI for assistance, as mentioned before, and establishing clear governance models for how the ontology evolves and updates are managed.
So to wrap up, the development of COREA is presented as really a critical strategic initiative for anyone serious about the future of AI in education. It's positioned as the cornerstone for this OMG framework.
Right, providing the structured curriculum knowledge needed to make AI accurate, consistent, and trustworthy.
And it's also seen as essential for empowering teacher-led initiatives like Team, giving them that reliable base to build on.
It's a vision for AI that truly understands educational content, not just mimics patterns. But the source is very clear that this is a significant, complex undertaking. The need for a thorough cost analysis is explicitly mentioned, acknowledging the massive investment required for building and sustaining this kind of infrastructure.
And the crucial next steps identified are very concrete ones. First, developing tangible prototypes like an AI-powered quiz generator explicitly built on COREA to prove the concept and demonstrate feasibility. You need to show it works.
Exactly. And then, rigorous empirical evaluation to actually measure COREA's impact and validate its benefits compared to current, less structured AI approaches. That evaluation step is absolutely key to demonstrating its value beyond the theoretical.
So here's a thought to leave you with. Imagine AI that doesn't just mimic conversation about a subject, but truly understands what needs to be taught and learned, guided not by statistical patterns alone, but by a structured, expert-validated blueprint of knowledge your curriculum. How might having AI grounded in your specific curriculum fundamentally change how you teach, how you learn, or how you build educational tools?
It represents a profound potential shift from AI as a powerful but sometimes unreliable tool to AI as an intelligent agent, reasoning about educational content based on a shared explicit understanding. It's a compelling vision, but one that requires significant collaboration and sustained effort to turn into reality.
Definitely a lot to think about there. That's all for this deep dive into COREA.
Thanks for exploring with us.